Hello Honors Pre-Calc students, Mr. Hazelhorst here with today's lesson on partial fraction decomposition. Again, might sound like a fancy term, but I think it's something over the next couple of days that you're going to see is pretty simple. This will be part one of 2 days in terms of partial fraction decomposition. Today we're just going to go through a little bit of an introduction and kind of the setup of the problems. And then tomorrow we'll add in the second half and complete the process of partial fraction decomposition. You should have a note sheet in front of you that you can use to take notes and follow along as we go through today's lesson. But we're just basically going to look at some examples today and then give you some time in class to practice. All right? So let's get started. So as an introduction to partial fraction decomposition, I want to take a look at the problem like the one you see on the slide right now. This is a problem that we would have completed in the past. All right, if we think about the left side of the equation, the left side of the equation is the problem that we would have been given in the past. You can think of this as our question. And the right side of this equal sign, this is what you would have been finding. We could think of this as an answer. All right, we know in the past that we would have taken the left side of this equation, we would have taken each of these fractions, we would have gotten common denominators, we would have added them together, and hopefully if we did that work correctly, we would come up with what we see on the right side of the equation. When it comes to partial fraction decomposition though, what we're going to do is reverse the process. All right, this is now going to become the question. All right, we're going to take this fraction, and the goal is, can we break it down into its fractional parts, hence the idea of partial fraction decomposition. So we're going to take the right side, what will now be our question, and the goal is, can we come up with these three fractions that make up that part? So that's what we're going to be taking a look at today. So here's kind of some details to this whole idea of partial fraction decomposition. We're going to come back to this slide throughout today's lesson. All right, but again, our goal is to break down a rational expression into its parts, its partial. Again, when we think back to the example that we just looked at on the previous slide, this is the exact opposite of adding rational expressions. And this is going to be an important concept that you're going to build in calculus. So what we're going to focus on today are the characteristics of the partial fractions, which you see on the right side of the slide. And we're going to mainly focus on the denominator and do just a little bit of work with the numerator, okay? So the first step as we take that problem, our first step is always going to be to factor the denominator. All right, we're going to factor that so that we can then set up how many fractional parts we'll have when it comes to our partial fraction decomposition, okay? Now, one thing that will also be important when it comes to the denominator is this idea of a repeated factor. What we mean by repeated is you can think of that as an exponent. If one of our factors is raised to a power, it's a repeated root, then that's going to be what we refer to as a repeated factor. And we're going to have to work with each possible degree. We'll look at that as we go through a couple examples today. So if you don't quite get that, don't worry too much about it until you see some examples. All right? So this is going to be the main brunt of our work, is the setup of the denominator. But we will do a little bit of work with the numerator. Now, tomorrow we'll deal with how to actually solve them. Today, as we finish our problems, our numerators are just simply going to be variables. Okay? And again, tomorrow we'll talk about how to solve for those variables. So as we think about the numerator, we need to take two things into consideration. And again, it all goes back to our denominator, making sure we factor that correctly. If our denominator is linear, then our numerator will be a constant. And you'll see this with some examples here in just a moment. If our denominator is quadratic, then our numerator will be a linear function. Okay? And it's important for us to think about x squared as well. X squared is going to be considered a repeated root, not quadratic. We'll deal with that here in a little bit, again, within some examples. All right? So what we're going to do today is just jump right into some examples. I have 4 example problems that I want to look at with you today. And I think by the time we get done with these, you're going to have a good grasp on the setup of partial fraction decomposition. All right, and again, this is a process that we'll finish tomorrow. But if we can't set things up correctly, that's going to cause us some headaches tomorrow. So let's take a look at some examples. So here's our first example, and our goal in this problem is just to write the form of the partial fraction decomposition. So when we say the form of the partial fraction decomposition, we just want to write out or determine first off how many fractions are there going to have to be added together to form this rational expression, and then second of all, what are their numerators going to look like in general. Okay, we're not going to specifically solve for those today. We're going to save that work for tomorrow. But again, just what will they look like in general. All right, so our work here is pretty simple. Our first step will always be to factor the denominator. All right, so we want to factor this. So if we think of the denominator, x squared minus x minus 6, remember our goal is to break this down into its fractional parts. Well, if that's the denominator, all right, the only thing that makes sense in this problem is that we're going to have two fractions in this problem because there's only two factors to the denominator of this expression. So if I factor this denominator, this would factor into x minus 3 and x plus 2. Now as you go through the setup of these problems, it doesn't matter what order we write the factors, just that we factor the denominator correctly. Now you'll see how that might influence some things, but we're not going to get too hung up on that here right now. Okay, so we're going to factor the denominator. Now at this point, let's go back to our slide with the characteristics here. This is where the idea about the numerator comes into play. So we have to look at what our factors are. Again, if our denominator is linear, then our factors are going to be constant. And that's what we have in this example. So let's go back to our example. So when we look at our two denominators, all right, both denominators are linear in their form. So that means the numerators both have to be constant numbers. Now, we don't know what those numbers are, so we're just going to throw some variables up there. And generally in partial fraction decomposition, we're just going to use capital letters. We're going to start at A, and we're going to work our way through the alphabet. So our numerator of our first fraction, we're just going to call A for now. And the numerator of our second fraction, we'll call B. And that's as far as we're going to go today. All right, this would be the form of the partial fraction decomposition. We know there's two fractions that will make this up. One will have to have a denominator of x minus 3. One will have to have a denominator of x plus 2. We know the numerators will both have to be constant terms. As far as what those are, we don't know at this point. And again, that's what we're going to set up, and that's what we're going to solve for tomorrow. Today we just want to go through this setup phase. So let's take a look at another example. Again, the first thing that we always need to do is we need to factor the denominator to determine how many fractions will make up the partial fraction decomposition. So let's take a look at our denominator here first off. The first thing I'm going to do with this denominator to factor it completely is I'm going to factor out an x. So that will leave me x squared plus 2x plus 1. Now I can factor that trinomial even further. So what we would end up with is x times x plus 1 and x plus 1. And this would be the factors of our denominator. Now here's an example of what we would consider a repeated factor. I could rewrite this to be x times the quantity x plus 1 squared. All right, let's go back to our characteristics page real quick. So again, when we look at our denominator, it says if a factor is repeated, we want to work with each possible degree. So remember, we had the factor x plus 1 and x plus 1. All right, so each possible degree of that repeated factor would be x plus 1 to the first and x plus 1 to the second. We want to work with each of those as a denominator because they could be partial fractions involved in the makeup of that rational expression. So let's go back to our example problem here and finish this out. So if we set up the partial fraction decomposition this time, here's what it's going to look like. We're going to have three fractions that will make up this partial fraction decomposition. We will have x, right, just coming from the x that we factored out. Then I would have x plus 1 to the first power and x plus 1 to the second power. Because again, this is a repeated root. So when we have this exponent, we have to deal with every possible degree of that function. All right? So when we look at it, we consider three factors here. We have x plus 1, we have x plus 1 quantity squared. Again, now we need to go back and fill in the numerators, and all of this is going to be determined on the degree, basically, of our denominator. So when I look at all three of my factors here, all three factors would be considered linear. Now, we might look at this last one and say, well, that's a quadratic. Well, no, this is just a linear function that's being raised to a power. So it's really what's going on inside of the parentheses that determines whether or not that's considered linear or quadratic. So since all three of these are linear, they're all going to have constant terms. So we'll say A, B, and C. And this would be the form of our partial fraction decomposition. All right. Again, we'll deal with how to solve this tomorrow. Today we just want to get it set up correctly. All right. Now somebody might ask, well, what happens if I write my factors in a different order? All right. If I wrote my x plus 1 first and my x plus 1 squared second and my x third, my a, b's, and c's won't match up to yours. And that's true. But tomorrow you're going to find out that really doesn't matter. It doesn't matter where A, B, and C are or what these variables are even. All they are is just variables. All right, they could represent anything. So we don't want to get hung up on what the numerators are as long as we have the correct form. Is it linear or is it constant? Okay, that's going to be the key. So don't worry too much about the letters that we put on top. Let's just focus on factoring the denominator correctly and getting the right type of numerator set up. Again, constant or linear. So far, all of our examples have been constant, so let's take a look at an example that's got a linear numerator. So here's our next example. Again, the first thing that we want to do, just like every problem we've done so far, is we want to factor the denominator. So if I take a look at my denominator here, x cubed plus x, I know that I can factor an x out of each of those terms, so let's go ahead and do that. So we pull out an x, that's going to leave us x squared plus 1. Now I can't factor what's left in the parentheses any further. That binomial is reduced down as far as it can go. And so now we're ready to set up the form of the partial fraction decomposition. All right. In this case, I only have two fractions that will make up this partial fraction decomposition. I have the x, and I have x squared plus 1. Now, somebody might look at that and say, well, that's pretty much the same as what we had last time, and we had the lesser degree. All right, well, this factor as a whole is not repeated. That's one factor, x squared plus 1. Remember, last time we had the squared on the outside of the parentheses. That's what made that a repeated factor. Okay, so let's go back to our characteristics slide real quick again and talk about, okay, what's the difference between a linear and a quadratic in the denominator? So when we look at our characteristics page here again, remember a linear denominator will have a constant numerator, but a quadratic denominator will have a linear numerator. And so let's take a look at what that's going to look like within our example here. So when we come back to our problem here, remember the way I have it set up anyway, the first fraction has a linear denominator, so it's going to have a constant numerator. So we'll just use the letter A again. All right. Now, my second fraction's denominator is quadratic, so that means it has to have a linear numerator. Now, we don't know the characteristics of that, what that linear numerator are, but we know anytime something is linear, it's going to have a slope and a y-intercept. All right, so those are the two variables that we have to include here. So when I look at the numerator of my second fraction with that quadratic denominator, we're going to write its numerator as bx plus c. All right, Now, again, it doesn't matter what variables we use in the numerator. It's just the fact that we have something to solve for, and again, we'll focus on that tomorrow, all right? But this is a great example to show us the difference between a linear denominator and a quadratic denominator. All right, and again, a linear denominator will have a constant numerator, and a quadratic denominator will have a linear numerator. Now, we could continue on with this process. If we had a trinomial denominator, that would have a quadratic numerator, but we won't get into problems that involve those, so we don't have to worry about that. All we're going to deal with are linear denominators and quadratic denominators. So we want to make sure that we can set up that thing, the numerators, correctly as we work through that. All right? Let's take a look at one more example because we have one more situation that we need to be aware of as we set up the form of a partial fraction decomposition, and then we'll let you get to start on your assignment today. All right, so here's our last example. When you look at this one, you might say, Mr. H, that's the same problem we just did, and it's not quite. Our denominator is slightly different here. So again, let's start out the same way, as always, with all of our problems that we've done so far. The very first thing that we want to do is we want to factor that denominator. So as I take a look at my two terms here, I can see that both of those contain an x squared. So we'll factor out an x squared, and that will leave us left with x minus 1. And so there's our complete factorization of this problem. All right? So a couple things that we need to take into consideration here, all right, as we take a look at this problem. First off, this x squared. Let's think about that for a moment. All right? Now, a lot of us, as we look at x squared, we might think, well, that's quadratic, all right? That's the parent function of a parabola, which is true. Y equals x squared is, but we're not thinking x squared as its own function. We're thinking of it as factors, all right? And when I look at x squared, all right, what I actually want to consider this as, if we were to factor this completely, this is actually repeated. Because if we were to write out the complete factorization of this denominator, it would actually be x times x times x minus 1. Okay? And so when we write it this way, we can see that yes, x is repeated. All right? And that's what we want to keep in mind here. We need to determine the types of denominators that we have. Do we have a linear denominator? Do we have quadratic? Do we have repeated? Right? All those things affect the form of the partial fraction decomposition. All right? So x squared is kind of unique, and we have that mentioned on our characteristics slide. So let's go back there for a moment. So again, as we take a look at the bottom of our slide here, all right, this is what we want to keep in mind, and this is what we're dealing with in this example, is that idea that x squared is considered a repeated factor, not quadratic. All right, so what's that going to affect? Well, remember, when we deal with a repeated factor, all right, that's going to help determine how many denominators we have. Okay, so let's take a look at that. Let's go back to our. So again, working with x squared is repeated. When I set up my partial fraction decomposition here, I'm actually going to have 3 fractions that will make up my partial fraction decomposition. I have x to the first and x squared. Since x is a repeated factor, again, I have to include every possible degree. So x and x squared, and then my last factor is x minus 1. Now, as I look at these, again, remember we need to consider their denominators and what their denominators are representing to help us set up the numerator, all right? Now, remember, x squared, we're not considering quadratic, we're considering it repeated. So even when I look at x squared in the denominator of my partial fraction decomposition setup, that's still being considered linear, not quadratic. So all 3 of my partial fractions here are considered linear in their denominator, so that means their numerators are all constants. So here would be our setup. A over x plus b over x squared plus c over x plus 1. Now again, that's as far as we're going to solve today, or as far as we're going to get today in the process of partial fraction decomposition. I just want you to get the setup correct. If you can't set up the problem correctly, obviously we're going to run into problems in the steps that are going to follow. All right, and this is the key part of any partial fraction decomposition, again, is all in the setup. So as you go through those problems today, be careful, think through the situations that you're dealing with in terms of the factors, and let's see if you can get those partial fraction decompositions set up in their correct form. Okay? So here's your homework assignment for today. I'm going to give you the rest of the class period today to work through these problems. Behave for the sub. Make sure you're focused and on task. We want to make sure that we have these problems done and completed, and we're confident in our ability to set up these partial fraction decomposition problems correctly. That'll make our work a lot easier tomorrow. If you do have questions over this, feel free to view this video again. It's posted on my class website. Remember, you can access that off the school webpage. Come see me tomorrow morning. Or if you just have some minor questions, we can address those at the beginning of class tomorrow as well. So I hope you had a great day. Enjoy the rest of it, and we'll see you back here tomorrow.
Made with Doodlecast Pro.